Hello, welcome to our next lesson where we'll start discussing statistical arguments. Statistical arguments are common arguments found in the sciences, and these are inductive arguments. Remember, inductive arguments are arguments where the truth of the premises means that the conclusion would follow by probability, not by necessity. So as we should expect, there can be varying degrees of strength that a conclusion can have in a statistical argument. Some conclusions can be more likely or more probable than others. So today we'll just look at some of the basics of statistical arguments, and the next lesson we'll look at how to construct good statistical arguments and how to criticize statistical arguments. So first, let's discuss general statistical arguments. So a general statistical argument is, well, it's a statistical argument where the conclusion of this argument is general. It's not about a particular member of a class, let's say, but it's a kind of general conclusion about a class in and of itself. So the first premise we can think of it by looking at the first column here, that the first premise can be something like this: P% of the n observed things in G have F. Therefore, conclusion, P% of all the things in G have F. Here, P and n are variables that refer to a number. So if we look at the first percentage, a certain percentage of the n observed, that itself is a number of things that I maybe perhaps tested or surveyed. And here G is a variable that refers to a group. So I observed a certain number of things in a particular group, particular members of that group, and I found that they have this feature. F is a variable that refers to a feature. Therefore, the conclusion, this same percentage of all the things in G have F. Notice in the first premise that there is the evidence that's presented is in regards to a certain subset of G. You're not observing all the things in G, but you've only observed a smaller number of those things in G, and you've found that there's a certain percentage of those things observed have a certain particular property. And then you extrapolate from this in the conclusion using an inductive argument, statistical inductive argument, that you draw a conclusion about F in regards to all the things in G. It's a general statistical argument where the conclusion is about all the things in G based on observations of only a smaller number of members of G. To give you a real-world example of this, it could be something like this. Let's look at the second column. First premise, 75% of 1,000 state students like beer. Conclusion, therefore, 75% of all state students like beer. Notice the extrapolation in a general statistical argument to all the members of people who are in the group of being a state student. Okay, and here we can think of P as corresponding to 75%, N as corresponding to 1,000, G is state students, and F, that feature, is likes beer. Okay, next let's look at particular statistical arguments. A particular statistical argument is a statistical argument in which the conclusion is about a particular thing. It's not general, but what we'll see in the conclusion is a conclusion about a particular member of a class. And as we're going to see here, the general statistical argument you can think of as being a kind of component part of a particular statistical argument. We're going to see elements of the general statistical argument in a particular statistical argument. So looking at things formally with variables, when we look at the first column, we can see the kind of general structure of a particular statistical argument. It'll be generally something like this. P% of the n observed things in G have F. Second premise, P% of all the things in G have F. Notice the first and second premise are parts of the general statistical argument. But now we have this, P3, X is a thing in G. It's a particular member of G. Conclusion, therefore, there is a p% chance that X has F, that this particular member of G has this feature, F. And to look at a real-world possible example of this kind of argument, we can say here, first premise, 75% of 1,000 state students like beer. Second premise, 75% of all state students like beer. P3, Kristen is a state student. Right? Kristen is a particular member of the relevant group G, being a state student. Conclusion, therefore, there's a 75% chance that Kristen likes beer. So this kind of argument is a particular statistical argument, and you can think of P1 as P2 and P2 as being a kind of sub-argument or a linked argument as compared to the overall main argument. It's a kind of general statistical argument that is a sub-argument that's going on in P1 and P2, which is then used along with P3 to help support the conclusion about a particular member of the group. Okay, so there are 5 general parts to a statistical argument. There are the observed things in G, right, of the overall group, while the things that are tested or observed are the sample. So, for example, the sample in our previous case is the state students who were surveyed. If you were running a political poll to see where people in the United States, which candidate they most closely lean towards, for example, to be a president of the United States, the sample would be those actual people that were interviewed. Right? That's the sample. N is the number of things in the sample. For example, in our previous example, in regards to liking beer and state students, the sample size was 1,000. So N you can think of as being the sample size. 3 is the features that these things have, the F. So the features that these things have, in other words, the F, is the relevant property. So we're going to use this term, the relevant property, to describe the feature that's being attributed to in the conclusion. So in our previous example case, it was liking beer. Number 4, all the things in G are the target. The target is, in our previous case, was all state students. Right? And in a general statistical argument, for example, we run tests on a sample with a particular sample size, and then we try to extrapolate a conclusion concerning a relevant property to all, or generally to all members in G, or in other words, the target. Number 5, P is the percentage of the observed things that have F. So in our previous case, in regards to liking beer, that was 75%. So it's the percentage of the observed things, in other words, the sample, that have F, right, in our testing or in our surveys or what have you. And that, once again, was 75%. You could have another component, right, if you have a, for example, particular statistical argument, you can have X, which, remember, was a variable that refers to a particular member of the target, or in other words, of G. Okay, so we should not confuse statistical arguments with analogical arguments. There is a difference between the two. In an analogical argument, you're comparing one group to another group. For example, jumping off of a bridge, everyone jumping off of a bridge versus everyone going to a party. So here in this analogical argument, you're comparing one group to a distinct group. The first group, let's say everyone jumping off a bridge, is not a subgroup of the second, namely everyone going to the party. These are two distinct groups. However, in a statistical argument, you're comparing one group, let's say that is the sample, to another group, which is the target. For a statistical argument, the first group is a subgroup of the second. For example, the 1,000 surveyed state students are a subgroup of all state students in our previous example. So you can think that statistical arguments that one group, of the two groups that are being examined, one of the groups is a subset of the other group. Meanwhile, for analogical arguments, the two groups are distinct. Okay, so let's look at some problem sets here. For each of these, identify the sample, the target, relevant property, and percentage. So remember, for these statistical arguments, there will be two groups. One of them will be the sample, one of them will be the target. The sample is those that are observed, is that group that's particularly observed or tests are actually run on them. So let's look at the first one. 5 Green Party members I have known are all French. Ralph Nader is a Green Party member. Therefore, Ralph is probably French. Okay, what is the sample here? What are those that are observed? Well, what's being observed here are the 5 Green Party members I have known. Right? That's what's being observed. So what's the target? Well, the target is the kind of more general class in which the sample is a subset. So the target is all Green Party members. Alright, so next, what is the relevant property? What is the property we're trying to draw a conclusion about, that we're trying to attribute to the target in this case, in this kind of argument, as well as here this is more of a particular argument in regards to Ralph, who is a member of the Green Party. What kind of property are we trying to attribute in the conclusion to Ralph? It's about being French, right? So the relevant property is about being French. And then next, what is the percentage? What is the percentage of members in the sample that are French? Well, in this case, of the 5 Green Party members I've known, all of them have been French. So here, the percentage is 100%. Let's move on to the next problem. The tigers in the San Diego Zoo all have stripes. Thus, all tigers probably have stripes. What is the sample? What has been observed? What is being observed? What is the group that's being observed? Well, the sample is the tigers in the San Diego Zoo. Right? Given the context of this passage, that's what has been observed. The tigers in the San Diego Zoo, that's the sample. What is the target? In other words, what's the second group, right, in which the sample is a subset of that target group? Well, it's all tigers. Next, what is the relevant property that's being attributed to tigers in this statistical argument? Well, it's having stripes. Right? Having stripes is the relevant property. Next, what is the percentage of the sample that has the relevant property? Well, in this case, the sample is the tigers in the San Diego Zoo, and it says here that all of them have stripes. So the percentage is 100%. All right, so next, let's look at this next passage here. I ate at the new Charlie's restaurant yesterday, and the food was pretty good, so I intend to eat there again today. It will probably be just as good today. Okay, so what is the sample? What is the actual observed evidence here that we've looked at? And the sample is, in this case, is yesterday's visit to Charlie's restaurant. Right? It was eating food at Charlie's restaurant yesterday. That was the sample in which we gathered empirical evidence, right, based on our senses about the taste of the food, at least what we consider, whether it was good or bad. What is the target? Okay, so what the target is something more broad. And what's kind of being implicitly stated in this argument here is that, well, since I ate at the restaurant yesterday, pretty much today, when I eat there again today, and perhaps maybe in any other day, it will be just as good. So the kind of broader group here in which the sample is subsumed is generally any visit to this restaurant, the food will be good. Okay, so what is the relevant property being attributed here? And the relevant property is the food tasting good, right? The food being tasty. And what is the percentage of the sample that has this property of where the food was pretty good, where the sample is only yesterday's visit to Charlie's restaurant. So therefore, it says that that visit, it was pretty good, the food was pretty good, so therefore the percentage is 100%. Alright, so that concludes our lesson, and I will see you for the next one.